Hi Jenny, it's Mike back. Can you actually hear me? Oh yeah, the host has disabled the video. I wonder if the host can re-enable our video. We're back in. Okay, so welcome back to the 5G Innovation Centre, or the 5G Lab. And Sammy, Michelle and Davide have given a great overview, building on the introduction when we were outside just pretend it was the sunny Gold Coast. It was sunny when we shot the opening scene on the weekend from the Smart Apartment. Davide, you gave a really great introduction to why standards are so important and why it's important that we develop them ahead of the technology. And I want to show you, this is a technical report that we prepared back in 2017, 2018, before 5G was launched. Now, I'm going to open to a particular part of this report, and you should recognise part of this, because if we can zoom in a bit, Jamie, this is actually inside the innovation laboratory here. So that's, we were doing the 5G testing well before launch, and Davide, you mentioned it was important to test to make sure that the networks were all compliant. We wanted to do it inside to look at what the in-building systems would be like, but we also wanted to do it outside, and we prepared some measurements that would go into this IEC technical report, and you can see that we've been out in the street, and again, this is sunny Queensland, so we had the 5G car going around doing all of the compliance-based testing. I'm very proud of TC106 to be able to accelerate the development of standards, because that's very, very important as we progress with this new technology. The polls have been exciting, all of the possibilities that come forward. We're going to show you how we're going to enable some of that possibility now. Davide, I'll just put this book down. Davide, you talked about beamforming before and the new technology. If we have a look on our big screens here, Jamie, if we just move up carefully. Now I'm assuming you can see this. This traditional 4G and 3G networks have antennas that send the radio signal out in all directions. So basically it's a wide beam, a wide signal, and whether you've got one device, 100 devices or 1,000, the signal is always there. If we go forward to 5G, some of the efficiency, well, a lot of the efficiency and capacity is going to be because of the beamforming abilities of 5G. Now Davide mentioned that, and Sammy mentioned that was part of the excitement in his work. This is literally what you might see. So the old 4G antennas send a signal in all directions. The 5G will identify where the devices are and send a small narrow beam to those devices. Now that means you're not sending energy to where you don't need it, it becomes more efficient, and you can get that faster connection and greater capacity. We're going to show you that live here in the 5G IC, or the 5G lab now, on the new high band network. So Jamie, if we move over here, now this is where live in the lab we hope works, and we cross our fingers. So I've got Tia. Now I don't know whether you can see the people here, but Tia is one of our young professionals working in Telstra. She's going to be activating 5G on this is the antenna we're connected to, I should say. It's up on just up on the railing. This is one of the new high band antennas. Now they're very, very small, but they're very advanced antennas because they can do this beam steering. Now Tia, if you activate a connection, I've got a device here that's a very sensitive RF device. It just detects radio frequency signals. I'm going to see if I can find the beam going to Tia's device. So if I move this, now I don't know whether you can hear that. Jamie, if you come in a bit closer, you might be able to see the device, and you can just hear the beeping noise, hopefully. That's the width of the beam going to Tia's device. Now Tia, if you turn that off, we'll see if it stops. So Tia's disconnected her device and the beam has stopped, just like in that photograph before. Now Sammy, you're over there. Have you got a device running?
Yep.
So let's see if I can find the beam going to Sammy's device. Right, I think you can hear that. Hopefully that's coming through. Now Sammy's got a device running, and Sammy, if you stop your one, it stopped. Okay, so we've only got signal going to the devices when they need to. Like Davide said, that's the advantage of beamforming. Now Tia, I'm going to give you a challenge. If you can turn yours back on, I'll just see if I found it. Now if you walk away, if you unplug the power, and maybe walk to the other side of the room and interfere with where the guys are playing games. Now that signal has just stopped, so I'm going to try and find where T has gone and see if there's another beam going to T's phone. There we go. I've just found the beam going to Tia's phone or Tia's device. Now I'll move back here, Tia, and if you just walk back, keep going. Right. I hope you could see that, because what that was is Tia was moving from one location to another, and we could hear the beam go past this detector. Now that's what we've done to simulate that, is we've artificially loaded the network. So we're running the network at a very high throughput. To do that, we're going to have a look at what that looks like on the spectrum analyzer, and then run something you're probably more familiar with, like YouTube or streaming. So we're running at around 1.8 to 2 gigabits per second with a high data stream. And this is the 800 megahertz of high beam or high band radio frequency signal. Now Tia, if you stop that, this should disappear, and we'll just wait for that to go down. But maybe most people won't be doing that when they connect it to 5G. Most people will be streaming, they'll be on YouTube, or they'll be connecting with all of those billions of devices I mentioned. But Tia, if we maybe connect YouTube and run a 4K video clip, so we're running 4K there. Now, what it does is when you're running video, it just says, whenever I need a bit of data, I'm just going to give you a burst. Now, it's not like we saw before. That's going to go down shortly, and you can just see those bursts of data. That's all you need to deliver the signal, or to deliver the signal to get that high quality video stream. So you certainly don't need the amount of signal that we had before. So that's just to show you what the example of, in terms of what the spectrum would look like. If I try and find the beam, it's not generating as much power now because it doesn't need to. This is what 5G will look like when you're connected. Now I'll turn this around. And because it's much more efficient and we have a very low, we don't need as much energy, I can't actually detect anything. So when you've got normal 5G, and this is what we've found with all of our surveys and when we've done the surveys for the compliance testing, 5G being very efficient has really, really low EMF levels and really low EME levels. One of the challenges in standards is to develop the testing methods, like Davide said. So this is what we're doing in the lab at the moment. We're feeding all of this research and all of our modelling and our testing into the new test methods when these beamforming antennas become operational. Now, the challenge for us is when you've got individual antennas sending beams to where people are, how do you actually measure that? And how do you write testing standards to do that? So that's the challenge that TC 106 has in the Base Station Standards Committee, and we're feeding our results into that group. So the last thing I'm going to show you, if we move over here, is we've been monitoring what the EMF levels have been through this whole experiment today, and the exposure standards have recently changed, and what they require is they require a measurement, or they require an assessment over 30 minutes. So they look at the average level over a 30-minute period. Now we've been measuring all of the 5G, 4G and Wi-Fi and all of the other radio frequency signals here over the last 45 minutes that we've been running. And Phil, what are we actually seeing on the screen? Well, in terms of the level, what are we seeing, Phil?
0.031%.
So if the limit is 100%, we're seeing 0.013, so almost 1,000 times below the safety limit in this room where we've got lots of high-tech 5G. Okay, I'll just show you one more comparison. If we come over here, I'm just going to reset this measurement range. So what we've got running on the table here is we've got some 5G phones streaming, and they've just gone off, but I'll let that go. I'm just getting my device back again. So Jamie, if you come in, this is the spectrum analyzer that we saw before. Now this measures the different radio frequency bands, and this is the exposure limit at the top. This is 100%, which equates to the public exposure limit. So that's the safety limit set by the international health agencies, and that is very, very conservative. So what I'm going to point out to you is this is 4G down at the 700 megahertz band. We've got 4G at 1800 megahertz. We've got Wi-Fi, we've got 4G, and this is the new 5G signal that most countries are using. This is what's called mid-band 5G. This is at 3.5 gigahertz. Now I'm going to run a speed test, and you'll see some activity on 5G. If I just hit the speed test, that should connect. And if you just come in a little bit, you should be able to see some activity happening on 5G, and it's just building up a bit there. So once that stops, that's just showing you what the peak is and what the average is. Let's compare it to a couple of things. So I'm going to turn on a baby monitor, and I'll just turn this one on. Baby monitors, depending on the type, they work on the Wi-Fi band. So when that powers up, we should see a connection from the baby monitor, and we can see the picture there. And Jamie, if you come in a little bit, you can just see the Wi-Fi band building up. Now that's the signal from the baby monitor. And it will vary depending on the picture that's